Hey, how you going? It's Patrick from North Australian Heavy Mechanical, and today I'm going to run you through one of the reels that I did, servo and control circuits. So basically what I'm going to do first up is give you my explanation for control valves, or MCVs. Just depends on what you're working on is what they call it. And it's basically low pressure switching high pressure, so it works exactly like a 12 or 24 volt relay. Low current switching high current, so instead of having contacts, they have spools that shuttle in either direction, directing the flow to where it needs to go, right? Basically that's done by servo or pilot pressure. Servo or pilot pressure just depends on the machine. It can be anywhere from 35 to 60 bar, but always refer back to the OEM maintenance manuals for those ones, because it does vary on the machine. So what's in an MCV or a control valve is basically an open-centered one is what they are, right? So what I mean by open-centered is when the spools are in the neutral position, any flow coming from the pump will be just going straight to returns. And what's in them to keep them in the neutral position, you have a spring on either side of your spools. They're housed in your spool caps. And then you have your mains and your secondaries, right? So they're housed in the control valve itself. Not always the case though, keep that in mind. Some main reliefs and secondaries can be remotely mounted. For example, the 340s, they're housed up on the high pressure filter housing. That's where the main reliefs are. And then, for example, the 996s, their secondary reliefs are housed up on the mono blocks. Up on top of the boom there. So always refer to the operation and maintenance manuals, and it's pretty obvious sometimes where these are located, right? And for example, a 9400 or 9350 main reliefs and secondary reliefs are all housed in the pumps, or not in the pumps, sorry, in the valve banks themselves. So the pump and valve bank configurations, right? So these large excavators are generally, for example, 996 has 4 valve banks. Valve bank 1, that goes to pump 1. Valve bank 2, pump 2, and so on and so forth, right? And then, PP1 and PP2, you've got 2 engines. Pump 1, both go up to your valve bank 1, right? So this is really handy for reference when you've got say for example, a travel deviation fault. So you've got it traveling to the right, you go and check your travel circuit, and it's traveling to the right. You can then go and use pump 1 and pump 3, isolate those two, do your cycle times on your boom. If your boom cycle times are down as well too, that means that you've got a regulation flow issue out of your pump or main relief. But if it's only, they're exactly the same as your other valve banks, then you know that you're looking at either a dead motor, a secondary, or so on and so forth, right? So that's a way you can split it up and work out whether it's a common fault across the attachment and the travelling. But every machine's configured differently, but when it's like that, you can work it out pretty quickly, right? It's isolation and elimination. So basically what activates our spools is pilot pressure, right? And pilot pressure is is directed to our spool caps via proportional valves or Ys and YRs, right? So proportionals on the O and Ks and Ys and YRs on the Liebherrs. And what Ys and YRs are on the Liebherrs is Ys is strictly on and off, and YRs are basically how much, so they're a variable proportional. And that goes to then, say for example, that's how they drop valve banks away from to give priority. So they drop Ys away. So for example, you pull boom up, all 4 valve banks kick into gear and all 4 pumps give flow to your boom circuit. But then when you pull a breakout implement, which a breakout implements is the bucket and the stick, that's what the operators use to dig with, right? It pulls valve banks away from your boom circuit and gives priority flow to your breakout implements. So those Ys and YRs is just basically giving it more control and giving more flow to the breakout implements, right? So servo circuits or pilot circuits, whatever you want to call it, they have a couple of things. They have their own pump You can have certain machines that will have self-pressure reducing valves, so they'll reduce mains pressures down. That's more common on the smaller excavators, but servo circuits on the large excavators, they have their own little pump, they have their own little circuit relief. It's anywhere from 35 to 60 bar, and the servo and pilot pressure doesn't just run the control side for your valve banks. It can run your auxiliary stuff like your grease pumps, service hatch, ladder, so on and so forth. So then you can, if you've got a slow ladder, for example, right, you might have slow ladder on one engine, that's going to be more likely a pump, but if you have a slow ladder on both, you could have a relief, and so on and so forth. But I just want to make sure that you understand that it's not just, the pilot pressure is not just there to activate our spool caps, to direct our flow. It is there to run our auxiliary circuits as well too. So what I'm going to do now is run through one of the more in-depth faults that I've had with it was a 6040 or 170, sorry, O&K. So basically the operator complaint was it was down on power and some erratic behaviours, right? So upon arriving to the machine, had a good chat with the operator and was like, oh, that sounds really strange, but anyway, we'll work it out. So jumped up in the machine, straight up, checked drift, checked cycle times, and then went through main reliefs. And as I was checking the main reliefs, did realise that the stick extend circuits, stick retract, sorry, was down on pressure, so I had a pressure loss in that circuit. And then when I went and checked my bucket main reliefs, I noticed that the stick was extending on its own. So on these control valves, on some of these large excavators, for maintenance purposes, they have what's called a Javi valve. And now what a Javi valve is it's a common little block that's tapped into the load side, so the closed side of the MCV between the cylinder and the valve bank, and it's there for maintenance reasons, right? And that Javi valve bleeds the pressure down so when you want to work on that circuit, you can bleed the pressure down and be sure that there's no pressure in that circuit. So in my head, had to eliminate that straight up, so capped off all the lines, still stick extending on its own. Then I went to the control side of it, so you can get earth dramas, electrical earth dramas, which I've had before. It's pretty common on the Lee Bears. Basically another circuit pulling earth through another circuit, holding that spool open, disconnected the proportionals to make sure it wasn't that, and then capped off our spool caps, or just disconnected our servo lines to the spool caps, and then that was what gave me the evidence and the proof to then go and say, righto, well, we've got a spool here that's not in the neutral position. And when I pulled the spool caps off of valve bank 1 and 2, valve bank 2 came off easily. Valve bank 1, the spool cap, as I undid the bolts, was lifting up and metal came out of it. So it was our stick extend spool was not returning to the neutral position, so it was slightly open. So whenever you'd use another function, flow was directing on up to that stick. So that was exactly the same fundamentals, the elimination process. So basically working through it, going, it's not this, it's not this, it's not this, all right, it's this. So it gives you the justification and the confidence to go and pull a spool cap, and also to hold that machine down. If you're eliminating things and it's still faulting, well, you're going to get there eventually, right? So another example that I have was a 996 that had recently had a slew box and gone back to work before the shift before, basically. So then the operator called up saying that he had slow, erratic operation. And when I went down there, I sort of had in my head already that they'd done a slew box, so they had to remove a heap of proportional lines. Went and checked the servo pressure straight up, and it looked good. And in the last video, I was saying that flow can compensate a pressure loss. When I was operating that machine, then I was watching the pilot pressure on the grease controller, and it was dropping away. So it was a pressure loss. And that time I did actually ring someone up. I always ring people up just to have a chat, and I don't think that I'm down there all the time being the hero, gutting it out. I like to bounce ideas off people and, basically the bloke that I rang said, yeah, basically go check your lines, and went through and checked the lines and found supply and pressure, supply and a return line crossed up on the pilot circuit, creating a pressure loss. And that's you know, 2 examples. Always, if you find a pressure loss, you got to chase that pressure loss, and it will lead you to where the fault is, you know, because when you rectify it, then you go back and you can pretty much tell straight away. If you've found a pressure loss, you go and fix something, and then you come back and that pressure loss is rectified, boom, problem solved. So basically, I'm going to go give you a bit of a recap of servo and control. So we have our control valves open-centered. They are basically low pressure switching high pressure, same principles as a 12-volt relay. Instead of having contacts, they just have spools. The springs keep it in the neutral position. Servo pressure is anywhere from 35 to 60 bar. Always refer to your operation and maintenance manuals. The secondaries and main reliefs can be mounted in the valve bank itself, but also can be remotely mounted either on mono blocks for secondaries or up on high pressure screens. Proportional valves is what directs our servo oil towards our spool caps. Ys and YRs on Liebherrs are Ys on and off, and YRs are how much. Auxiliary circuits are run by servo or pilot pressure. So ladders, grease pumps, service hatches, and always elimination when it comes to chasing faults. If you find a pressure loss, chase that pressure loss and rectify it before moving forward. So if you've enjoyed these videos, like, share, subscribe and comment, because it all helps. And you know, I want to grow this thing and I want to keep doing videos. And if you're enjoying them, you know, like, share, comment and subscribe. So cheers, thanks very much.